All right, up to this point, we've only dealt in terms of right triangles. Our law of sines and law of cosines, these next two sections that we're going to cover, say, no, guess what? You don't always have to have a right triangle ever, right? So you can always look at congruent triangles and the concept associated with that and go with our law of sines. So let's do a quick geometry review here. Side, angle, side. That means I have a side, the angle between, and then the other side. That is going to be congruent to the side, the angle between, and the other side. So 1 dash means those are equivalent. 2 goes with 2, etc. Side, angle, side. That's a guaranteed congruence. If two sides and the included angle of one triangle are equal, respectively, to the other one, then those triangles are congruent. Angle, side, and angle. All right. Side, angle, side. Angle, side, angle. And this is in order. And it has to be touching exactly the very next one. That's the key. So if you have a side, the angle in between it, and then that side. I can't have this side, and this angle. This is an order. Side, angle, side, angle, and side, side. All right? Those are congruence axioms is what they're called. So if that criteria is met, then you know you have congruent triangles, and then you can work with it. Okay, so we're going to use those kinds of concepts here and to talk about the law of sines. So in any triangle, ABC, with sides, little a, little b, little c, because we know that goes with the sides, the following hold. So here is law of sines. Side A goes with the sine of A, angle A. Side B goes with the sine of angle B. And side C goes with the sine of angle C. Now this is, so I have any triangle, right? This is not a right triangle. This is just any triangle. So across from A is still A, across from C is still C, and across from B is still B. So this is what it's talking about. This relationship for any triangle, if I have this relationship, then we're good to go. I know that A goes with A, B goes with B, and C goes with C. So you have to have the side and the angle relationship in order for law of sines to work. Because these are ratios, alternatively, you can have your angle on top. Oopsie daisy, oopsie daisy. Oops, oh my goodness. The angle has to go on top here. So you're just using those different relationships, all right? So either one, if I'm looking at this, either one of these, where you have the side on top or the angle on top. The biggest thing is the sides all have to be in the numerator and the angles all have to be in the denominator, or vice versa. You can't swap them back and forth. Either the angles are on top or the sides are on top. You don't get to mix and match. All right, so here's one more tip, and the reason why we look at both of these. Good practice is to put the unknown in the numerator. So if it's the angle that you're trying to figure out, well, put it in the numerator. If it is the side you're trying to figure out, well, put that in the numerator, right? Whichever one is the unknown, that's your good practice to put in the numerator because it's easier to solve that ratio that way. All right? Okay, law of sines. Set up your ratio. That's your law of sines. Okay, now, oblique just means not right, right? That's just that. So here are 4 different cases. 4 different cases for solving oblique triangles. These first two are going to deal with the law of sines. The bottom two are your laws of cosines. All right, so we'll get to that in 11.2. But for us right now with our law of sines, we're looking at side angle, angle, or angle, side angle. If you have two angles, right, two angles, then you can use law of sines. If, and this is going to be the fun one here, if you have two sides and one angle, then that's called an ambiguous case. This may lead to 0, 1, or 2 triangles. If you have two sides and an angle, there's no guarantees. It's kind of the whole situation. And we'll look at criteria associated with that because that's going to be our last examples that we go through. But for now, if you have these two cases, then that's law of sines. If you have two sides with an included angle or side, side, side. If you're heavy on the angles, here, two angles, automatic law of sines. If you have two sides that are next to each other, that's law of sines. If you have an included angle or three sides, those are your law of cosines. Okay. And you'll be able to see it, and it'll be obvious as we work through these problems of what's going on. All right, let's try one out. Here's example 1. We want to solve triangle ABC if, are given here, angle A is 32.0 degrees, angle B is 81.8 degrees, and side A is 42.9 centimeters. Now here's the deal. Anytime you have a matchup, that is law of sines. So you can look back through, oh, side angle, single, blah, blah, whatever. Here's the moral of the story. Anytime you have this matchup, pardon me, that is law of sines. All right? That's your biggest thing. If you don't have any side and any angle matched up, then you go to cosines. All right, so let's do it right now. I like to, whenever I have this, go ahead and write out, if I'm solving for a triangle, I like to write out what I've got. I have angle, angle, angle. I have side, side, side. For this one, I know that I have 32.0 degrees is A because it's given. B is 81.8. And side A is 42.9. Okay, I have to figure out angle C and then these two sides that go with it. Well, what's the easiest thing to figure out here? Yeah, your angle, right? Because I know a triangle is 180 degrees. So if my triangle is 180 degrees, I'm just going to take 180 minus that 32 minus that 81.8. Chug that out in your calculator. And you get 66.2. So now I have my C. All right. Now here's the deal. I've got to find these other two side measurements. Of my other two side measurements, I have to match them up. The whole concept of law of sines is setting up these proportions. So A is the one that's given. So anytime you are given a proportion, use it. So my unknown is going to be my sides. So my sides are what are going to go in the numerator. So I've got 42.9 over the sine of 32 is equal to B over the sine of 81.8. Cross multiply anytime you have a rational, these two proportions equal to each other, then you cross multiply, right? So I've got B sine of 32 is equal to 42.9 times the sine of 81.8. Divide both sides by the sine of 32. And B is now equal to whatever that is in the calculator. Now notice for this problem, it doesn't even say, oh, round to such and such, whatever. In this, you know, for your significant digits, I have to 1 decimal place. I'm going to continue to have to 1 decimal place. So when you plug all of that in, B is equal to 80.1 centimeters. Try plugging that in your calculator. Keep in mind, these angle measurements are inside functions. So plug that in and make sure you're coming up with the same thing that I am. If you're not, then you need to be contacting me and we need to make sure we get that figured out. All right, so there's B. Let's find C. Go back to what you're given. Don't go with this rounded business. Go back to what you're given for your proportion. So I've got 42.9 over the sine of A is equal to side C and the sine of 66.2. Do your cross multiplication again. Oh, shoot, dang. I put A in there and we all know that it's 32. I'm going to scoot this up just a little bit here. And 42.9, the sine of 66.2. Divide both sides by the sine of 32. C is now equal to whatever the dickens that thing says in your calculator. 74.1 is what I come up with. All right, if you're not getting that, make sure you're checking it. First of all, you have to be in degree. So if you're getting something crazy, keep in mind we're talking about degrees here, so you have to be in degree mode. And then you can plug that in. Good. This looks like an 87. That's an 81. Oh, dang. All right. Now, here's something else I want to pull off. Anytime you have a triangle, the side and the angles are proportionate. I mean, we just figured that out, right? All of these are proportionate. Your biggest angle has your biggest side. Makes sense, right? Your smallest angle has the smallest side. So that's a fail-safe check for you. When you're going through here, make sure you do that quick look. Okay, big to big, small to small, and in the middle. Okay.